Kia ora and welcome to video 13 of Agile Algebra. In this video, we're going to look at a problem involving a pyramid and a cube, and we're going to be led through this by another former student, Nicole. So here is the problem. We see that there is a cube inside the pyramid, and we need to find out the volume of that cube. Now, our guest presenter, Nicole Muir, is a wonderful young lady. She's currently studying at university. But when she was with us at school, she was not only extremely hardworking and very intelligent, but also very well-rounded. For example, she was in our first 11 football team, and I did get to see a few of those games while she was playing in the team, and she was a very, very good player. So a lot of our scholars and you watching this will know that it's important that you don't just focus on your studies. So of course, studies are important, and working exceptionally hard will get you results in the short term or even the long term. But it is important to maintain a healthy work-life balance, and Nicole definitely had that on lockdown. So without further ado, we'll pass the video on to her, and she'll explain how to go through this question. Pause it and give it a go first, of course. All the best.
Hi everyone, I'm Nicole. I was in Mr. Walden's scholarship calculus class 2 years ago now, and today I'm going to be taking you through this question here. So the question asks, if the pyramid has 8 1 centimeter edges, what is the volume of the cube inside? So the square pyramid has 8 1 centimeter edges. It is a regular shape. All the sides are the same length, so pretty good. So the way that I kind of wanted to approach this question was by actually taking kind of a cut of the shape, so slicing it somewhere and then looking at the 2D drawing of the cut, basically. So because this is a slightly easier question, I'll be taking you through 2 cuts. So first one being the diagonal cut, goes from corner to corner of the base of the square pyramid, and also corner to corner of the base of the cube. The next cut is the side cut. So as you can see, it goes straight through the side. Yeah, don't really know how else to explain that. But yeah, so the diagonal cut is a slightly longer method, but it means that we can use the side cut to verify our answer, to just check it, make sure it's all good. So we'll start off with the diagonal cut. So what does the 2D drawing look like when we cut it through the diagonal? So first off, I guess the cube is not going to look so cubey. Because we're cutting through the center, the width of what is coming from the cube is going to be more of a rectangle. It's not going to be so much of a square. So yeah, I guess that's the main thing. So it's probably going to look something a little bit like this. Yeah. So this is our 2D drawing. Now we can put in some lengths. Those are going to be important. So we know that these diagonals, they're going to be 1 centimeter. And the height of the cube is going to remain the same. That's going to be x. I'm just calling the sides of the cube length x. Yeah, pretty standard. Anyway, so there are 2 lengths that we don't know yet. Those are the bases, pretty much. And how can we find these? Well, we can go back to the square pyramid and the cube and look at the base, because these lengths here are just going to be the diagonals. So just draw out some diagrams, just squares, pretty standard, and then we can use Pythagoras to work out the length of the diagonals, which will be root 2 and root 2 times x. So pretty simple. So moving on, we can cut this 2D drawing in half to create two right angle triangles, but we can just take one of them. Don't need both of them. And then we realize, oh no, we don't have the height, but it's all good. We can use Pythagoras again to find out the height, which turns out to be 1 over root 2. So, perfect. Now we have a right angle triangle with lots and lots of known values. So, plug that in. And now, what we can do is we can use similar triangles. So, the bigger outer triangle is going to be a similar triangle to the inner triangle, the smaller triangle in the corner, because the base angle, or the angle to the right, down the bottom, is going to be the same for both of the triangles. That is good, because it means the ratios of the sides will be equal. So what that means is when we divide the height of the triangle by the width, that is going to be the same for both triangles. Same ratio. You can also think of it as taking a tan of the angle. So tan of the angle angle to the right of the bigger triangle going to be equal to 1 over root 2 divided by root 2 over 2. And that is going to be the same as tan of the angle of the smaller triangle, which is going to be x over that big expression there. So, because those are equal, we can make one big expression with x's and a whole bunch of numbers which we can solve. So, after some rearranging, we get to x is equal to 1 divided by 1 plus root 2. Awesome. But we're not quite done yet, because the question asks for the volume. So, what do we have to do? We have to cube x. You know, base times width times height, all that good stuff. So, when we cube x, we get minus 7 plus 5 root 2, which is approximately equal to 0.071 and centimeters cubed, because units are good. So, yeah, awesome. We got to an answer, but now we want to verify it, I guess. Always a good thing if you have time in the exam. So, what can we do? We can use, that's the answer. We can use the side cut, which is hopefully going to be a slightly shorter method. So when we do the side cut, our 2D drawing is going to look something like this, with the cube, or the 2D drawing of the cube looking a lot more cubey, which is good. So now we put in values again. Awesome. We know the base this time. We know that the full length of the base is going to be 1 centimeter, same as the base of the square pyramid. And then we know the base of the square bit is going to be x, the length of the side of the cube. Okay, what we don't know, however, is the diagonal. And why do we not know this? Because the length from the top of the square pyramid down to the middle of the base, middle of the side of the base, is not going to be the same as the side length of the square pyramid. They are not going to be equal. So, might have to do a bit of working to find that out, and that is what we are doing next. So, if we look at the flat side of the square pyramid, one of the flat sides, what we can see is we actually have a right angle triangle. Very helpful. So, what we can do is we can draw out this right angle triangle. We can put values to it. So, this diagonal here is going to be the same as the side of the square pyramid, and that is going to be equal to 1 centimeter. The base is going to be equal to half of the length of the base of the square pyramid, which is going to be 1 over 2, or 0.5 centimeters. And then we are trying to find this length here in yellow. So I've labeled that Z, you can label it whatever you want, but using Pythagoras, good old Pythagoras, we get to the value of root 3 divided by 2. So we can put that value in there, and awesome, we have a whole bunch of values, it's amazing. We can split the triangle in half again, make 2 right angle triangles. Again, we only need 1. So, should be able to see how I've got all these variables here. The height I've just gotten from the previous working with the diagonal cut, but you are more than welcome to put in some more working, verify that it is indeed 1 over root 2. you'll find out that it is, and then we can go on to using similar triangles again. So, as you can see again, we have a bigger triangle, and then we have a smaller triangle, and they are similar triangles because the base angle is the same. So again, we can use the same. The height divided by the width is going to be the same ratio for both of them. So 1 over root 2 divided by a half is going to be the same as x over a half minus x over 2. So I did do a little bit of rearranging, which is why it's 1 minus x all over 2. That's from the base of the smaller triangle. I've just rearranged it. It's right. So again, we can rearrange the equation, find x, and whoop-de-doo happens to be 1 over 1 plus root 2, as we expected. So we're almost very confident that we've got it now. Unless something has gone drastically wrong at the very beginning, we're pretty much like 100% confident. So again, just to verify, v is going to be x cubed, and again, you get that as negative 7 plus 5 root 2, which is approximately equal to 0.071 centimeters cubed. And yay, we've done it. But yeah, anyway, hopefully this video helped. All the best with your studies. Yeah, thanks for listening.